Okay, today you are going to learn about segment addition and midpoint of a segment. And just make sure that you're taking notes so that when you go to class, you haven't forgotten anything and we can dive right into some more, to some challenging problems and constructions in class. Okay, so we're going to begin with talking about distance. We all know about distance. We've been talking about distance in class, and we've been talking about distance on the coordinate plane. Okay, the coordinate plane, okay, has your x and y axis, and we know that we can be given points. Okay, let's say we have 2 points, okay, and we know that we can take those 2 points and we can connect them, okay, and a lot of us have been thinking about how we're going to find distance, and I think a lot of us have decided that maybe Pythagorean theorem is going to be the best way for us to do that. So with Pythagorean theorem, you draw in your dashes, you make your right triangle, and we can find the length of that segment between the points that we were given. Okay, distance is the same thing as length. Distance means that you're finding the length of that line segment. That is a segment on the coordinate grid. Well, we don't always have segments on a coordinate grid. Sometimes we just have segments. And what I mean by that is, let's say we have just a number line. So here's our line, and this is our number line, and I'm just going to label it with a few values, as many as I can fit here in the line that I've drawn. Okay, so our number line goes from -4 to positive 3. Sorry about that. So there's our number line. If we had those points labeled, if we could label those, all right, let's do that. Let's put A here. Maybe we'll put B here. Maybe we'll put C here. Okay, and I could ask you, what's the length of AB? Okay, and most people would just say, well, that's pretty easy. I'm just going to go and I'm just going to count. That's 1, 2, 3 units. So I know the distance of AB, or the length of AB, is 3 units. Okay, I could also find the distance from B to C, A to C, whatever you'd like. AB, BC, and AC are segments within that number line because they have endpoints, so they are segments. Okay, it's important to really know the definition of distance. Distance is really just the distance from 0. Okay, it's the absolute value, the distance from 0. There can't ever have a negative distance. Even if you run backwards, you've still gone positive distance. Okay, now that we have a good idea of what distance is, we're going to talk next about congruent segments. And I'm sure most of you already have an idea of what congruent means. Okay, congruent in this case means that the segments have the same length. Okay, so I'm just going to write that underneath here, that the segments have the same length. Okay, and when we talk about congruence, we use the equal sign with the tilde above it. Okay, that means congruent. So when you're talking about congruence, you have that symbol. Okay, congruent means if I have 2 segments, let's see, let me draw 2 segments here. Okay, so I have, let's say, this segment here, let's call that segment AB. And over here, I'm going to draw in, and let's call that segment MN. Okay, those 2 segments, let's say this one is 6, and this one is 6 inches, or whatever it might be. Okay, those 2 segments are congruent. A couple things that you need to know. You're going to mark this, and marking in geometry is very important. Okay, I'm going to mark it with this little dash on each one. That little dash is called a tick mark. And tick marks indicate that things are congruent. So I know by looking at that picture that those 2 segments are congruent, and that means that AB is congruent to MN. Okay, they're congruent. They have the same length. Now my picture is not perfect, but we're just going to use the congruent and what they're the congruent tick marks and the label that they're both 6, and use that diagram to say that AB is congruent to MN. Okay. With congruent segments, we can do a lot of things. And one of the things that we're going to talk about is using those to help solve problems. And the first kind of thing that we're going to do is segment addition. Okay, so we are going to talk next about segment addition. All right, the next thing we're going to talk about is the segment addition postulate. Okay, it is kind of what it sounds like. Okay, that we're going to be adding segments together. All right, the definition of segment addition is if B is between A and C, then AB plus BC equals AC. All right, I don't know about you, but I always like to have a picture of what I'm talking about. So if I draw a segment, and I have that segment AC, somewhere in there, B is between A and C. So I'm going to put B right here. I don't know exactly where it is, but I know it's between. Okay, by doing that, I can see the picture here that AB, this part, plus BC, this part, equals AC. So again, this part here, AB, plus BC, is going to equal this whole segment AC. Okay, that's segment addition. All right, with that, we can, make it a little more difficult now. And, by now, we kind of see that we like to add an algebra into the geometry class. Okay, so let's say we have a problem over here to the side, and let's do R, S, and T. And let's say that RS is 2x plus 7, and ST is 28. And let's just also say they tell me the whole length is 4x, and I need to solve that problem. All right, so I'm going to think about what segment addition is, and I'm going to write out first what I have. I know that RS plus ST equals RT. I'm writing out my segments. Okay, so I've written out my segments, and I can now plug in what I know. All right, RS is 2x plus 7, ST is 28, and RT is 4x. And I would solve that just like I do an algebra problem. Okay, I'm going to have to slide over here now. So I have 2x, 7 and 28 make 35 equals 4x. I would divide by 2x. I have subtract 2x. So I have 35 equals 2x. And then I would divide, and I would get that x is 17.5. So x is 17.5. If I plug that back in over on the picture here, if I plug in 17.5 back into the picture, 2 times 17.5 is 35, plus 7 is 42. So 42 and 28, this 42 and 28 together make 70. So when I plug in 17.5 with the 4x, I should also get 70. So 17.5 times 4 is 70, so I've checked my work that RT is in fact 4 times the x value, and I know that I've done the problem correctly. So that's segment addition. You're just literally taking two segments, adding them together to get the total length. All right, the next thing we are moving on from now is midpoint. All right, a lot of us know about midpoint already. We've all probably talked about it in our Algebra 1 class. And we know midpoint as, again, starting just like we did with distance, on a coordinate plane, a grid, okay? And we know that if we have 2 points, so let me put 2 points on here. Let's say I have a point here and a point here. I could connect them if I wanted to. Okay, I could use the midpoint formula. I'm going to write it out here. I could use the midpoint formula, and I could plug in, and I could solve for the midpoint on the grid. Okay, and again, remember, you don't have to memorize the formulas because they're going to be on the formula sheet for you, but it is good to know. If you know that off the top of your head, it's going to make your life just a little bit easier. But we've done that type of midpoint before, where you can plug in the x and y values and solve for the midpoint. And in this place, you get a point that's halfway between the endpoints. So if this is A and this is B, when you get your midpoint coordinate, you would check it and make sure it looks like it's in the middle. So I don't know, middle to me kind of looks right about there. That would be my midpoint, halfway between A and B, meaning AM would equal MB. Okay, they would be the same length. A to M would be the same length as M to B once I find my midpoint. Well, in geometry, remember we're talking about congruence, having the same length. So that's also AM, it would be congruent to MB. Two segments split up by the midpoint are congruent. So midpoint bisects a segment. It cuts a segment in half. It's halfway between the two endpoints. Okay, so there's midpoint on the coordinate grid, or there's just midpoint of a segment. Let's say, for an example, we have a segment, and let's make this segment XY, okay? And let's make M the midpoint. All right, going back to the beginning of the notes today, we're going to talk about using our tick marks to show that they're congruent. So that's telling me that XM is congruent to MY, so M must be the midpoint. If I had some algebra in here, I can start to solve a problem. Maybe they tell me that this is 5x, and maybe I know that this is 3x plus 4. Well, since M is the midpoint, and XM and MY are congruent, I can just set those two values equal, two parts of the segment there, equal and solve. So I would get 2x equals 4, so x equals 2. Okay, well, let me take that one step further and let me plug it in here. Okay, so I'm going to take that 2 and I'm going to plug it in. 5 times 2, well, that's 10. 3 times 2 is 6, plus 4 is 10. So I know that my two parts are supposed to be congruent, and they are. I've solved and plugged it in correctly to check my work.